Hello guys, welcome back to a new session. In this session we'll be talking about the section 3 of chapter 10, which is about the types of the reaction. We have got 4 types of reaction. Let us talk about the first type, which is the substitution reaction, guys. The substitution reaction refers to the when two molecules are reacting to each other, produce two other molecules in the product by substituting the atom or atoms between each other, guys. In which one or more atoms replace another atom or groups of atom in the molecule. Have a look on this example. Here we have got methane and then chlorine, Cl2. To produce two other molecules in the product, chloromethane and then hydrogen chloride. In this, from the methane, a hydrogen goes to the chlorine, and then a chlorine replaces the hydrogen. So each they replace each other in order to form two other molecules, two new compounds in the product. Have a look on the other examples, guys. Here we have got the chlorine with the chloromethane produced what? Dichloromethane and hydrogen chloride gas. The chlorine goes to replace one of the hydrogen, and the hydrogen to the chlorine produces the HCl and CH2Cl2 in the molecule. More examples or shapes of this type of reaction, which are the substitution reactions. We have got dichloromethane with the chlorine. A chlorine is going to replace another hydrogen, and hydrogen goes to the H to form HCl, and then here we form the trichloromethane, which is a common name of chloroform. And then the chloroform reacts again with the chlorine, replace it to become tetrachloromethane plus hydrogen chloride, which is the carbon tetrachloride or tetrachloromethane CCl4. The substitution reaction, guys, as I told you, two molecules are reacting to produce two other molecules. They replace the atoms. One is going to replace the atom in the other molecule. Notes about the substitution reaction, guys. In substitution reaction, additional compound can be formed by replacing the other hydrogen atom remaining in the methane molecule. When the chlorine replace or any other atoms replace the hydrogen, there will be formation of the compounds. For example, dichloromethane, if we add 1 Cl more to the CH3Cl, it becomes CH3Cl2 dichloromethane. Or more addition, it becomes trichloromethane, which is called the chloroform. And then if we add more chlorine, replace more hydrogen, it becomes tetrachloromethane, which is carbon tetrachloride, CCl4. CFC are formed by the substitution reaction of the chloroalkane with the HF. We talked about the Freon 11 and Freon 12, which are in the alkyl halide. In the alkyl halides, we talked about the Freon 11 and the Freon 12, guys. Here in this case, when we have CCl4 reacts with HF, the one of the Cl replaced by the F, and to produce HCl or the Cl replaced, and then F inserted to the molecule, it becomes Freon 11. And then another one, when we have CCl3F, there will be replacement. One F goes to replace the other Cl, and then Cl goes to the hydrogen to produce HCl, and then Freon 12, which is CF2Cl2 in the structure. In general, substitution reaction, we have got two reactants to produce two products in the product side. The addition reaction is another type of reaction which we have. In an addition reaction, it's simple to recognize this type of reaction, which we have got the molecules unsaturated, it become more saturated in the product. Unsaturated, it become more saturated in the product. In addition reaction, one or more, one in which the atoms or molecules are added to an unsaturated molecule, increase saturation of the molecule. So the addition reaction increase the saturation. From unsaturated, it becomes more saturated. From double bond, it becomes single bond. From triple bond to double bond or single bond, as we can see. A common process that we have, and it's the addition reaction, is hydrogenation. Hydrogenation, hydrogen atoms are added to unsaturated molecule. The double bond is replaced by the hydrogen, removal of double bond, and then inserting hydrogen to the molecule. An example for this, vegetable oils contain unsaturated fatty acids. Vegetable oil, the liquid oil. When we process the liquid oil under the hydrogenation, it becomes a solid saturated oil, and then long chain of carbon atoms that have many double bonds. Here the vegetable oil has many double bonds, and then undergo through a saturation hydrogenation process by inserting the hydrogen, removes the double bonds, inserting two hydrogen. If you want to remove more hydrogen, remove this, add more hydrogens, it becomes more saturated. So in this process, guys, as the double bond converted to single bond, increase the saturation of the molecule in this hydrogenation process. The molecule still consists of a long chain of hydrocarbon, but it contains far fewer double bonds. The number of the double bonds reduces. The conversion of these double bonds to single bond changes the material from the oil contains double bond, which is liquid, into a fatless double bond, which is a solid. And the hydrogenation process, hydrogenated fatty acids or the oils are dangerous because of becoming more saturated fatty acids. And the fatty acid for vegetable oil contains double bonds which are unsaturated, undergo through hydrogenation to become more saturated and increase the saturation process by the addition reaction. We have got two notes. In addition reaction, two reactants are converted to one product. This is one of the signs to recognize the addition reaction. The second unsaturated compound changes to a less unsaturated or more saturated compound. Double bond goes to the single, triple to double, and the single. That's the sign to recognize the addition reaction. We'll be talking about the elimination reaction, is just the opposite of the addition reaction. As you can see here, the 1-propene goes to form 1,2-dichloropropane. It becomes saturated. The triple bond goes to the single bond, or triple bond to the double bond, are all the process of addition reaction, and it becomes more saturated. Alkyne changes to alkene by addition of bromine. Saturation of molecule increases in the above example, and alkene changes to alkane by addition of more hydrogen or the more halogens to that structure to increase the saturation. The third type of the reaction is the condensation reaction, which two molecules are going to be condensed and usually form water in the product, guys. In condensation reaction is one in which two molecules or parts of the same molecule combine to form the longer chain, longer molecule in the product. A small molecule such as water is usually removed during the reaction. As I told you, water usually will be produced. That's a sign of a condensation reaction. An example here, we have two amino acids which contain both amine and carboxyl group is one hydrogen from the amine group, one hydrogen from the amine group of one amino acid combines with the hydroxyl from the carboxyl group. They combine it, the H from the amino acid, combine it from the amine, combine it with the OH from the hydroxyl group, and then they form it a longer chain, a longer structure with H2O. Two small molecules form a longer molecule with H2O. That's a condensation sign. Notes about the condensation, guys. Here we have got two notes. In condensation, two reactants produce two products. But what's the difference between this and the other type is that two functional groups condense and form another functional group. How? Here we have got ethanoic acid with ethanol, which they do have two different functional groups. They combine to produce ethyl ethanoate, only one functional group. Or we can say simply, two small molecules are condensing, combining to produce a longer molecule with H2O usually. The last type of the reaction is elimination reaction, guys. In elimination reaction is just the opposite of the addition reaction. Addition reaction, we said there will be increasing in saturation of the molecule. Unsaturated becomes more saturated. Here the saturated becomes unsaturated molecule. An elimination reaction in which a simple molecule such as water or ammonia is formed from the adjacent carbon atoms of a large molecule. First example of an elimination reaction is the heating of ethanol in the presence of concentrated sulfuric acid. A hydrogen atom bonded to one carbon atom and hydroxyl group bonded to the second group atom removed from the ethanol molecule. Here we have got the ethanol in the presence of H2SO4. The ethanol becomes the OH with the H combined to produce H2O, the water molecule, and then instead of removing these two bonds, it becomes a double bond. As you can see, a single bond becomes double bond, so it reduces the saturation, it becomes more unsaturated substance. Second example is on the sugar, which is the example of elimination is a dehydration of sucrose with concentrated sulfuric acid. We talked about this in the properties of the acids in the section chapter 2. The sulfuric acid has a tendency to dehydrate the sugar, and that dehydration is elimination reaction, which the compound becomes more unsaturated. The sugar is dehydrated when it reacts with the concentrated sulfuric acid. Elimination of water produces a compound that's mostly carbon. In elimination reaction, generally one reactant changes to two products. Generally, we have got one reactant changes to two products. That's a sign to recognize the elimination reaction. Saturated compound change to unsaturated, unlike the addition reaction. Elimination reaction decrease saturation of the molecule. This is important to recognize the elimination reaction. Have a look on these reactions, guys. Let us examine whether they are elimination or not. Here, as you can see, we do not have double bond, but here they become double bond, and the OH with one of the H formed the H2O. One molecule produces two molecules. The one increases the unsaturated molecule. Alkane by elimination convert to alkene. Alkene by elimination convert to alkyne. So a single bond by elimination convert to double bond, by elimination convert to triple bond, increase the unsaturation and decrease the saturation of the molecule, guys. That's the end of the section. Thank you for the attention.